All right, we're now going to talk about the skidded turn and skidded turn stall. The skidded turn, compared to the slipping turn, gives us some very fascinating and dangerous aspects to our flight. And I want to cover those relatively thoroughly so that we understand, for one, what to avoid and how to avoid the skidded turn and skidded turn stall. Let's do a quick review here and just understand. I'm going to use my trusty Piper Malibu here, and this particular airplane has a, well, somewhat tapered wing, but for all intents and purposes right now for our discussions, we'll consider it a rectangular wing airplane. All right. My pin here is going to represent relative wind. Now remember, in coordinated flight, when the ball is in the center, the relative wind is parallel to the fuselage of the airplane. And for a rectangular wing, that means the relative wind is flowing perpendicular to the leading edge of the wing. Now, as the wings produce approach critical angle of attack, then your rectangular wings are going to have a certain stall pattern develop. In other words, boundary layer separation is going to happen on a certain portion of the wing first. For most rectangular wings, that's going to happen at the root. First, and then spread outboard as angle of attack is increased. For a tapered wing, that boundary layer separation is going to happen farther out on the wing, around midsection at the trailing edge. And then for a swept wing airplane, like mini jets, the stall pattern is going to happen at the tip first. And as angle of attack is increased, then that boundary layer separation or stall pattern works its way in toward the wing. Now, let's look here at this typical scenario for the skidded turn leading to a skidded turn stall. And that's turning base to final. We've probably heard about this before. Turning base to final on a close-in visual. The pilot, now it doesn't have to be on a close-in visual. It could be turning, base to final, like on turning vectors to shoot the localizer and intercept the localizer. The situation is that the pilot is now in his turn. He's in coordinated flight, all right, relative wind right down the nose, and he's realized that he is going to overshoot, either overshoot the localizer or overshoot final, but he's in his maximum angle of bank that he's willing to do at this point. He's put himself, it doesn't matter what the angle of bank is, it could be 30, it could be 45, could be 60 degrees angle of bank. It doesn't matter what that angle of bank is, but he's wrapped himself up in this angle of bank, this maximum angle of bank he's willing to do. And as he looks out, he sees that he's going to overshoot. And rather than go around or increasing angle of bank, one of those two options, he decides, well, I'm just going to help it around with the rudder. In this case, inside rudder, right? If he's in a left turn, he's going to boot left rudder. Start pushing on the left rudder to help, try to help the airplane in the turn. Now let's see what that does. If my pin here is relative wind in coordinated flight, now watch what the nose does as he boots in left rudder in this case. Notice that the nose went to the left and down, didn't it? All right. So now the relative wind is at an angle. Now, but notice when the nose goes down and the left, what does a pilot do when the nose goes down and he doesn't want it to go down? He begins to pull back. Exactly right. And of course that's increasing angle of attack on the wings. Now the relative wind's at an angle. Now do you notice the shape now, in essence, of the wing? In this particular case, the lower wing. Notice the relative wind angle. In essence, he's now turned his straight wing that he had in coordinated flight, he's now turned it into a swept wing with swept wing stall characteristics. All right? So let's follow this through here a little bit. First of all, when he boots in left rudder and the airplane begins to yaw, the ball begins to drift to the high wing, comes out of the center, drifts to the high wing, and now the airplane has a tendency to do something. What is the secondary effect of yaw? It's roll. It's always roll, and in fact, the airplane now begins to increase its angle of bank from the yaw that he's generating. Well, remember, he's at his maximum angle of bank, so what does he do? He begins to cross control. He begins to feed in right aileron, trying to hold the wing up, hold himself in his angle of bank that he's willing to do. Now, as he does that, what does that do, of course, to this aileron out here? It begins to go down, increasing the local angle of attack on this portion of the wing. And remember, this is the swept wing now with swept wing stall characteristics out here at the tip. So let's follow this through a little bit. Now that he's pushed inside rudder and he's actually pulled back, increasing angle of attack and cross-controlling, what is his premise? Well, the premise is that he believes by putting in more rudder than he needs to remain coordinated, that it will actually increase his turn rate. It will actually prevent the overshoot. Well, is that really the case? Let's see. If my pin now represents the lift vector of the airplane, let's see what happens to the lift vector, and we know that in a turn, it's the horizontal component of the lift vector that actually generates the turn. Now notice what happens to the lift vector as I boot in right rudder here in my turn. As I boot in left rudder. Notice as the nose went down into the left, it didn't change the lift vector, did it? It didn't move. In other words, all the pilot has done is taken himself from a nice coordinated low drag efficient turn to an inefficient high drag skidding turn. In other words, he's still going to overshoot. He's still going to overshoot in his turn. Now he feels better because the nose is pointing more at the runway. It looks better. It's an illusion though. It's an illusion as he's in this turn. So what does he do? What does he do when he realizes, oh, I'm still overshooting? Well, he continues to feed in more rudder and more backstick and cross control. Continues to feed in more left rudder. The nose goes down into the left. He has to pull back more to hold the nose up. And more right aileron, more cross control. Now remember, this happens in about 2 seconds, all right, this whole scenario, and he eventually pulls himself right into the stall. And let's see what happens to the airplane when it stalls in this cross-controlled scenario. Remember that this was the swept wing now based on the relative wind in this cross-controlled situation, and so it has stall characteristics going to happen out here at the tip. So that means center of pressure is going to move inboard and forward, so the lifting moment arm of the wing is actually getting shorter, the lifting moment arm. Now the center of pressure on this wing is actually going to move forward and outboard, so it's actually getting longer, the lifting moment arm is. So when it stalls, what do you think the airplane's going to do? It's going to roll. And sure enough, it will roll the short direction, and provided if the pilot does not do something quickly and efficiently, the airplane will stall, and next thing you know, he's going to be upside down looking at a face full of dirt. And what do you think normal pilot reaction is right here? To pull. Yeah. And it's the last thing he does in his life. Now, well, interestingly enough, when we're training guys in the skidded turn, we're trying to show them what leads to it and what are the warning flags that lead to a skidding turn. We're also training them how to recover from the skidded turn. Now, not necessarily because it's survivable, though. In fact, if you do a skidded turn stall in the traffic pattern, by the time you effectively recovered the airplane, got it rolled upright, and trying to pull away from the ground, you'd hit the ground. You are too low in most base to final turns to do an effective, safe recovery from a skidded turn stall. So it's a killer. It's a killer. The key to this whole thing is to avoid the skidded turn stall and to understand, first of all, that a skidding turn does not do a fixed wing pilot any good. Helicopter pilots can skid helicopters all day long, but a fixed wing pilot, there is no aerodynamic benefit to doing a skidded turn. And it can be a disastrous result if the flight controls are fed in too much, resulting in a stall while in a skid. So there you have it. The big picture is we've got to avoid the skidded turn stall. Thanks for listening, and hope you enjoy the discussion.